everyone, welcome back to another video regarding your course Chemistry for Engineers. So in the last video, we actually talked about the basic concepts of your crystal structure, and now we continue with the second part of your module number 2. This is your instructor, Engineer Janaika A. Tapiador. So continuing module number 2, which is entitled Engineering Materials. So these are the topic learning outcomes. Let me just read it to you again. So at the end of this module, you should be able to discuss the different engineering materials, particularly your crystals, metals, polymers, and nanomaterials. And of course, you are to solve problems on your crystal lattices. So we are already done with the basic concepts of your crystal structure in the previous video. Now we deal with your metals. So this will be the content of this particular video. You have your introduction to your metals, and we take a look at the physical and chemical properties of your metals. So it says here, all the things around us are made of 100 or so elements. And these elements were classified by Antoine Lavoisier into metals and non-metals by studying their properties. So this is a picture of Mr. Antoine Lavoisier. The metals in your periodic table of elements are divided into your subgroups. You have your group 1 metals, which is here. So these are your group 1 metals, followed by your group 2 metals, which is here. And of course, your group 12, I believe it's somewhere here. 12, 13, 14. But just to be sure, we will be taking a look at each group. So group 1 metals. Group 1 metals are actually called your alkali metals. Your alkali metals are actually abundant in minerals and in your seawater. So if you take a look here, you have your lithium, your sodium, potassium, rubidium, and your cesium. So let's go back to the periodic table. So it says here, your group 1 metals, lithium, sodium, potassium, rubidium, cesium. Actually, francium is supposed to be a part, pero hindi na siya pinakita dun sa next slide. So these are the different properties of the following metals. So as you can see, MP will stand for your melting point, BP is your boiling point, ND here will stand for your density, particularly taken at 20 degrees Celsius in the unit of grams per cc. So, makikita nyo siya dito, diba? As you go down the trend, bumababa po yung boiling point. Same is through, or rather melting point. Same with the second column. As you go down, so from lithium having the highest boiling point among the group 1 metals, pababa din po siya ng pababa. And in terms of density, so lithium, pinaka less dense. And then, as you go down, pabigat po siya ng pabigat. So, your group 2 metals are your beryllium to radium. And they are called your alkaline earth metals. So, let's take a look again at the periodic table so that we can identify which are your group 2 metals. So, again, it's from beryllium to radium. So, there, it's from beryllium, magnesium, calcium, strontium, barium, and radium. So let's take a look at some of the properties of this particular metals. So you have your melting point. Again, as you go down, the melting point decreases. And in the boiling point, they actually vary. And the density, as you go down, pabigat siya ng pabigat. So there. So group 2 metals are called your alkaline earth metals. And now let's go to your group 12 metals. So group 12 metals consist of your zinc, cadmium, and mercury. Let's go back and take a look at where they are in the periodic table of elements. So dito siya, zinc, cadmium, and mercury. So, let me make that correction. Dito po yung ating group 12 metals. There they are. Zinc, cadmium, and mercury. Sulfide ores of zinc, cadmium, and mercury of group 12 metals serve as raw materials in your metallurgy. These metals are located immediately after the transition metals in the periodic table of elements, but they do not behave like transition metals. So as you can see, very different naman yung kanilang properties. If you take a look here at zinc, diba? Its melting point is at 420 degrees Celsius, medyo mataas. Same is true with your cadmium. However, if you take a look at mercury, ang kanyang melting point is negative 38.8 degrees Celsius. Among all of the metals that we have, only mercury is in its liquid form at your normal, or rather at your standard atmospheric conditions or your standard conditions. So mercury lang po yung liquid. So I believe you have already encountered this. Hopefully, usually they are the ones that is being put inside your mercury thermometer. So nasa loob. Kung nabutan nyo pa, it's that silver liquid inside your old thermometers. Now let's go to your group 13 metals. So aluminum, among group 13 metals, exists as aluminosilicates in the Earth's crust and is more abundant than iron. The properties of aluminum are well known as it is widely used and encountered in your everyday life. For example, in 1 yen coins, your aluminum foil, cooking pans, aluminum window sashes, etc. So, you will have here group 13 metals starting from your aluminum, followed by your gallium, indium, and tellurium. Let's take a look at where it is located in your periodic table. So, let's go back. So, there are aluminum, gallium, indium, and tellurium. They are your group 13 metals. So, balikan natin. So these are some of their properties. You have the melting point, boiling point, and of course the density. So let's take a look at the very last group of metals. We have here your tin. It says here, of the 10 isotopes of your tin 118 is about 24.22% and your tin 120 is 33.59%. They're the most abundant among the 10 isotopes of tin that you can find on Earth. Metallic tin is present as your alpha tin or gray tin, which is stable below 13.2 degrees Celsius, and your beta tin, which is stable at higher temperature. At low temperature, the phase transition is quick. So this is actually an example of your tin in its raw form. You also have your lead among the group 14 metals. So your lead 208 is the most stable among the 4 isotopes, and it exists or among all of the lead isotopes, 52.4% of those lead is your lead 208. Lead is the end product of natural radioactive decay and has 82 protons. The atomic number 82 is important as it is especially stable. Thus, your lead exhibits high abundance for a heavy element. Kasi diba, if you recall what we did in your nuclear chemistry, starting from your uranium, diba yun yung pinagawa kong activity sa inyo? So you are to write the nuclear reactions involved in the decay of your uranium to lead-208. So lead-208, kaya napakadami niya kasi yung mga radioactive materials na present, parang ito na yung kanilang stable state. Parang ito yung target nila para maging stable sila. So, let me just recall. So, group 14 metals is your tin and your lead. So, let's go now to the physical properties of your metal. So, we will be talking about a few physical properties of metal. So, the very first one that you can actually see is that they have a shiny appearance. Diba medyo ano sila, shiny. Yun na yung term eh. They show, this shiny appearance means that they are actually showing a metallic luster. So makikita nyo dyan, metallic luster. Due to their shiny appearances, they can be used in your jewelry and decoration. Particularly your gold and silver are widely used for your jewelry. In the olden days, your mirrors were actually made of shiny metals like your silver, since silver is a very good reflector, meaning that whenever a light passes through your silver, it reflects 90% of that particular light. Kaya maganda yung reflection when the mirrors were made out of silver. All modern mirrors contain a thin coating of metal. Yung mga mirrors naman po natin ngayon, meron pa rin siyang metal content, although very, very little. Another physical property of your metal is that mostly they are harder to cut. Their hardness varies from one metal to another. Some metals like your sodium, potassium, and magnesium are easy to cut. Pero most of them, mahirap po siyang i-cut. So these are just a few examples of your metals which are easy to cut. So pag tinitingnan nyo, nandun siya sa bandang group 2, if I'm not mistaken. Group 2 metals. So another physical property is that metals on being hammered can be beaten into thinner sheets. This property is called malleability. So when we say the capability of metals to be hammered into very thin sheets, this property is called your malleability, meaning they are malleable. Gold and silver metals are the most malleable metals. That's why lagi silang ginagamit diba sa jewelries and everything, kasi it will require na dapat yung kaya mo silang i-form into very, very thin materials. And another here is your thin aluminum foils, which are widely used for safe wrapping of your medicines and your foods. So another property of your metal is called your ductility. Now, when we say ductility, this is the ability of the metal to be drawn into very thin wires. So, kung malleability into very thin sheets, when we say ductility, it's into very thin wires. That's why, diba, sa mga wiring natin, diba, it's made out of usually of your copper wire. So, this is an example of your copper wire, diba? Ayan, yung mga ganyan. So, it has the ability to be drawn into very thin wires, which we actually use in your copper wires. And another physical property of your metals is that they are good conductors of electricity. So if you take a look here, electric wires in our homes are of course made of aluminum and copper, and electricity flows most easily through gold, silver, copper, and aluminum. Gold and silver are used for fine electrical contacts in computers. Copper wires are generally used in electrical appliances, while aluminum is cheaper and is generally used to make electric cables. So pag medyo kailangan natin ng very, very fine electrical materials, especially in your computers and your gadgets, we go to your gold and silver. However, pag yung mga bulky lang or yung mga tamang pang-connect lang naman, we use copper or aluminum wires. So another physical property of your metals is that they are good conductors of heat. That's why, diba, yung mga cooking utensils natin, especially your forks, ano pa ba, yung mga pans, ganyan. They are usually made out of iron, copper, and aluminum because yun nga, they are very good conductors of heat. Kumbaga nadidistribute nila yung heat throughout the material. Another property is that metals are generally sonorous. So when we say sonorous, that is, they make a ringing sound when struck. Therefore, they are used for making bells, and metal wires are used in musical instruments. So sonorous, they have that ability to make that particular sound. Kaya ginagamit siya sa mga instruments nyo, like your drums, di ba yung guitars, di ba yung sa mga gitara nyo, yung mga wires, they are made out of metal. And another one is that most metals are very strong. That's why they are hard to cut. Diba? Yun yung, I believe, yung second property na tinignan natin. So metals such as iron are very strong. Therefore, it is being used mainly in construction, like your bridges, your railway lines, carriages, vehicles, machinery, etc. So, as I've said earlier, all metals except mercury exist in their solid form at room temperature. Therefore, they retain their shapes under normal conditions. So, mercury is an exception to the rule, but mostly all of your other metals are in their solid form. So, another one, metals have high melting point. So, this is, I believe, your group 1 metals. So, di ba pag magkikita niyo yung melting point, ang tataas, parang 1,287 degrees Celsius, 650, 842, 777, 727, 700, respectively for the following metals. So, medyo mataas yung kanilang melting points. Also, metals generally have high tensile strength. That means, di ba, mahirap silang ma-break. So, they can be stretched to some degree without breaking. Metals like tungsten has high tensile strength. So, di ba, pag yung mga metals kasi, di ba, ang hirap niyang i-bend. Kung kaya mo na siyang i-bend, parang you can stretch it out without it really breaking. Not unless ma-surpass niya na yung kanyang breaking point. So let's go now to the chemical properties of your metals. So it says here, metals, when burned in the presence of your oxygen, combine with oxygen to form your metallic oxide. So again, metals plus oxygen will yield a metallic oxide. As with the example provided here, for example, you have your magnesium metal, 2 moles of that, and a mole of oxygen, and when they combine, it will form your metal oxide or your metallic oxide, which is in this particular reaction is your magnesium oxide. So, ganito yung mechanism niya. Of course, yung metal na magnesium, it has that 2 valence electron, and pag magko-combine sila, that 2 valence electron will be lost. Diba? I-donate niya po yan sa oxygen. Ayan. Such that magnesium loses 2 electrons and oxygen gains 2 electrons to have an octet. Now, I believe octet is already a term that you are familiar with in your chemistry in high school. Parang, ito kasi yung goal ng mga elements to have 8 electrons for them to become stable. That's why it's called the octet rule. So, si magnesium, sobra siya ng 2, ibibigay niya kay oxygen para si oxygen makompleto. This is an ionic bond, meaning the electron is donated or given up. So, forming your magnesium oxide. So, it says here, different metals react differently with water. Sodium reacts violently with water, forming sodium hydroxide and hydrogen. Magnesium reacts mildly with water but vigorously with steam. Zinc and iron react mildly with steam. Copper and gold and silver do not react with water at all, and most metals on reacting with water produce hydroxide. So very different sila, although they are metals in general, they are very different when we let them react with water. So as you can see here, this actually picture entails that you have your sodium and it was added in your water. So as you can see, there was a very violent reaction. On the other hand, this is your magnesium and it is being reacted with steam. So makikita nyo naman siya dito. Magnesium here is burning in water, steam in the form of steam and not oxygen. So water lang to in the form of steam pero very vigorous yung kanilang reaction with each other. And as stated, your copper, gold, and silver, they do not react with water at all. So it says here, metals differ in their reactivity with acids. Most metals react with acids to produce salts and hydrogen. So magkakaiba din when we add them to acid. So let's take a look at this particular chemical reaction. So you have your magnesium, which is in the solid form. And then you add that into your hydrochloric acid, it will actually produce your hydrogen gas and your magnesium chloride. So ganito yung kanyang reaction. Parang mag-form siya ng bubbles, releasing your hydrogen gas and your magnesium chloride. So this is it initially. Ganyan yung itsura niya initially. Tapos ganun, magkakaroon siya ng chemical reaction. And then again, metals replace other metals when an iron nail is placed in a test tube containing copper sulfate. The nail is coated with a layer of copper with the blue copper sulfate solution has turned greenish. The green solution is a solution of iron sulfate. Ginawa nyo na to sa experiment number 3, metals and some aspects of corrosion. Diba dun sa mga experiment, makikita nyo na nag-iba ng color yung nail, ganyan. Pero kasi ang hindi pinakita doon, may mga metals kasi that when you try to put it in the solution, tapos nag-react siya, nagbabago din yung color ng solution. So as you can see here from blue, which is your copper sulfate, diba, iron, ni-replace ni iron yun, and then yung solution, hindi na siya copper sulfate. Naging iron sulfate na siya. Single replacement or a single displacement as they call it. And another one, most metals corrode when they are exposed to the atmosphere. This is very evident, diba? For example, the iron gets rusty after some time if it's not painted. Titanium is highly resistant to corrosion. So generally, all metals corrode. It's just that some metals takes a longer time for them to be corroded. Pero mostly kasi, di ba sa bridges, then sa railways, ang ginagamit natin is iron because they are very strong. However, di ba, over time, pag hindi na maintain, nagko-corrode yan. That's why, usually, initially, ang very cheap na gawin is to repaint. So, ipipaint nyo yan para kahit paano magkakaroon siya ng protection against the atmosphere para hindi mag-oxidize yung ating metal. Although we have metals which are highly resistant to corrosion, an example of that is your titanium and of course your stainless steel. Stainless steel is just a mixture of metals. So I think that's it for this particular video about your metals. For the next topic, we will be dealing with polymers. And I hope you enjoyed listening to this very short video. At least medyo short lang tayo ngayon class. And as I always say, stay home, stay healthy, and stay safe. Goodbye everyone!